Okay, so the first section, I would say quite a bit of these questions would be on a not calculator. We're going to do this. We don't need a calculator to do any of this. Okay, distributing. Here's my first question. This is a binomial, and I'm timesing it by a trinomial. When I'm done, how many different terms would I get? If there's 2 in this and then 3 in that, and I've distributed, how many terms would I end up with? 6. Yeah. 1, 2, 3, 4, 5, 6. Okay, so first times first makes first times second. First times second. First times last. Okay, and then you have to repeat that process. Second times first. Second times second. Second times last. Okay, I often use the word simplify. So simplify means, yep, we have to multiply. That's part of the simplifying. And there's also another part to simplify. Collect. Is there anything that can be put together as a collection? X, Y's can be put together. So you're going to have to rewrite it. And it doesn't matter what order these things are all in, as long as you have all the parts somewhere. Even my grade 11s and 12s, like, what does the word simplify mean? Multiply out, collect things, that's simplifying. So the next question has a binomial squared. Okay, here's how I want you to think about it. You are squaring this unit. You can't treat it like this. You can't square this and this individually. That's not going to work. So what does it look like if you square a unit? That is me squaring it as a unit, not squaring individuals. Big concept. Okay? And again, lots of my grade 11 and 12s are still getting that wrong. I keep hammering that concept in. You square the unit, not individuals. Okay, now, what would we call this process when you have a binomial? FOIL. Okay, can you FOIL that out now? I would say there'd probably be a very high likelihood of both of those questions being on an exam. Okay, factoring and solving. So what's the difference? So do you understand this in math is called an expression. This in math is called an equation. What's the difference between an equation and an expression? It equals to something, okay? When you are done an equation, you should make a statement. In this case, x equals something, okay? An expression is different. You're not solving for anything at all. Okay, so this says to factor and then solve. So we've done factoring quite a bit in the last few days. Give me your 4 types. Rolling off your tongue. GCF, what else? Difference of squares. Simple trinomials. Complex trinomials. Boom, recognize. What is it? Difference of squares. So that's the first part of it, is the recognition. Then go into your strategy. So the difference of squares is 2 brackets. Then you say what times what makes this, and you want them to be the same. So 5x and 5x. And then what's important about the signs? Plus, minus, and then you're thinking what times what makes 81, and you want it to be itself. Okay, this also is a solving, so do you see how I carried an equals 0? What is the solution? What makes that 0? So if you forgot the shortcut, I have a little bit of a shortcut. If you forgot that, simply think what makes that 0? How do you solve algebra?
Subtract them both by 9.
Subtract 9.
Divide by 5.
And divide by 5. And what is my shortcut? Opposite divide. It's always opposite divide. Do you see how that went? Opposite divide. So what is the solution on this bracket? Positive 9 over 5 makes that 0.
Is that what you just did, like, absolutely necessary to do in the question?
Like this piece wasn't right here. If you just remembered your opposite divide rule. Did you just say opposite divide? Yep. Okay, recognize we got a style of
GCF.
GCF is the style. Trinomials are already out because there's no 3 parts, right? So that's already out. So there's 2 terms. What could I possibly take out of each of those 2 terms? An x. And then there's 2 terms. So I should have 2 swivel arrows here.
Okay, that's the notion.
Yep. X times what makes x squared? X times what makes negative 16x? Do you understand when you factor, you can check. If you multiply it, it goes back to this top, right? You're going to have 2 solutions for x. If you want that first multiplier to be 0, x would need to be 0. And if you want that second multiplier to be 0, x would have to be positive 16, right? Opposite. So opposite. And then you can really think divide, but you're dividing by 1. Opposite divide. If you want to keep always thinking opposite divide, well, opposite is 16 divided by 1. Okay. Third example here. Style, recognition. simple trinomial because the 3 parts and because it starts with a 1x squared. So simple trinomials always begin with x times x or whatever letter you have. And then we have 2 rules. We always say it has to do something and something. It needs to multiply and it needs to add. So then, I have my times table on my exam. And 8 times 6 makes 48. And I need it to be a -2. So what are the 2? There's 2 solutions. I could have x be what? +8 or -6. Fourth example, recognize the style. Complex trinomial, right? Because there's the 3 parts and it's not a 1. Okay, so you need to understand how to strategize. Where do I start? If there's a complex trinomial, what is the strategy? So here it was multiply to the end and add to the middle. What's the strategy to do this one? I'm going to do some work on the side. What kind of work would I start with?
Yeah.
Flow number, which is -30. So let's see where I'm getting the -30 from. First times last. Okay, now I need some 30 sets. 130, 215, 310, 5, 6. I need a set that's going to make me 13, not a 130, not a 5, 6. That could make 13 and that could make 13. One of them is correct and one of them is wrong because of my signs. Let's go back to our flow number. It was -30. So what do you know about signs if it's negative?
Positive.
One's positive and one is negative. So which set do you have to pick to make 13?
15 and 2.
You have to pick 13 and 2 to make 13 with a positive number and a negative number. So the 10 and 3, to make that 13, they would have both been positive, and now I'm not getting the positive 30, or the -30. Okay, give me the separate F list, L list. How could you make the F? Okay, now it's the partnership time. You got to puzzle this thing together. Give me a partner that would produce a 2 and a 15. What with what? What with what? I should have given a few more spaces on that question here. Okay, we're going to go 2x and 3x in the first, because I'm foiling backwards. I'm undoing the foil. So there's my first times my first.
Yeah, I'll be in a Honda Civic. He's gonna be in the Honda Civic.
Okay, there's my connections to my outside inside part of my foil. There's your puzzle. Puzzle it together now. Okay, so on the outside, let's do the 2x with a 5. So that's creating a 10x. Whoa. No, just kidding. I don't want that. Undo. Undo. I don't want 10x. I want 2x with a 1. And boom, negative. Then on the inside, we're going to hook the 3x with a 5 plus 15x. This is an equation, so now I still have to make a statement x equals. So x equals, can we shortcut this? Opposite, divide. Opposite, divide. Okay, here's my strong recommendation. On an exam, if I'm factoring, especially with these complex ones, why don't I go somewhere on the side and FOIL it out and see if I get back to my original question, right? Your brain will work way better going FOILing than factoring. So then check it out. Okay, this one is just a factor. There's no solution. It's not an equation. What style is it? GCF. So there's 3 terms. So what is the most? Let's talk about the number. What's the highest number that we can divide out? 4. How many x's, how many y's? What would be the most? Just an x. And there are 3 terms. So there's going to be 3 connections here then, like that. So 4x, what do I still need to multiply by to get to that first unit?
XY squared.
I need another x and I need a y squared. This would just be
4.
minus 4 and 2x squared. Okay. Signs, there's always signs that separate different terms, right? Plus, minus, whatever.
You can factor it more, right?
If you have GCF this, then no, because yeah, this isn't, that's not like a trinomial, that's not any of the styles, no. Okay, this one, I say factor more than once. So first of all, what is the style you would pick? GCF. There's 3 terms. What would you like to take out of all 3? X. Okay. Now what? This. I'm looking at just this part now. It can go more. So what is that piece? Simple trinomial. So 2 numbers that make 30. When you do what operation? They have to do what to 30? Multiply to 30. Got some numbers that multiply to 30. And add to negative 11. And yep, this person has made a mistake. What mistake did I make here? I also need to include the x. Because if I was to multiply it back out, it should make it to the top. So I still need that extra x in there yet. Okay, graphing. Okay, can you put on the top of your paper y equals mx plus plus b. That is one equation that we worked with. Do you remember what the letters m and what the letters b meant? M is called a slope. Slope is a what over what?
Rise over one.
Rise over run. And the b was the y-intercept. Okay, the other equation that would be on your formula sheet would be this equation. So you can see the rise number and the run number. And the x1 and y1 would be a point. Just somewhere there'd be a point. Do you remember that I go opposite?
Yeah.
I'm going opposite because the equation says to negate x1 and I have an x1. So whatever I see for the point and the formula are opposite of each other. So plus minus. Okay, here we go. So I'm going to start. -7 is my y-intercept. I am going to go up to 3 right and draw another point. And that's it. Now it's just a line and arrows, right? Put arrows on your line. I feel like I did quite a bit of graphing lines as multiple choice on your test. Okay, what do we know about this one? So this one, we need to list a point and the slope. So what is the coordinate of just a point somewhere? What should we write? What comma what is the coordinate of a point on this line?
I don't know. 5.
-5,
Positive 8.
+8. Because the formula says whatever's here and here are the x, y values of a point, but opposite because of the, if I subtract an x1 and subtract a y1, but then I want x1, I need to do the opposite of what I see. In other words, here's how I can think about it. Does it make sense if I do x subtract a -5? It gets written as x plus 5. And the slope is -4 over 3. Once you have that, a point and a slope, you can graph.
So then the -4 and the 3 they don't switch, they just stay the same.
Right, because the formula is the rise here and the run here. So then I just pick them just straight out.
The other two swap.
Yeah, because looking at the formula, there's a negative sign in front of them in the formula. That's why. And they're the same because they're just rise. Boom. Just look at it and take it. Yeah. So -5, 8. So draw me a coordinate there. -5, 8. From that point, you got to go down 4 and right 3. Okay, also remember the fact that if you're a negative slope, your drawing needs to look like you're sliding down a hill, right? If you're a positive slope, you always got to be climbing up the hill. Everyone's good with that line? Fifth. So there you can see my slope, right? Down 4, right 3. So these formulas will be on your formula sheet, but there's not going to be pointers like this is that, this is that. I'm not going to do that for you. So you have to know what they are. Okay, what should we do with this? Yeah, get the y alone. Okay? So here's what I'm going to do. I'm going to do algebra, and I want to look like this when I'm done. I want to look like this, which means isolate y, get y alone. Okay, here we go. Keep y. So negative 2y equals. I am going to move the x stuff over. What happens when you move something in math? Opposite sign. So negative 5x on the right hand side and negative 10. Then what do I do to get y alone now? Divide by negative 2. Okay? Algebra is like children. If you give candy to one child, what do you think you have to do? Give candy to all of the children, or else somebody will be mad. So I get y. What happens in math with these two negatives? Just a positive. And I'm going to leave it as 5 over 2, but I'm going to write positive.
Why did you make them all negative? Why can't you just...
You could have done the other way around too, but I'm just going to always do this method so that my y is just y equals mx plus b. It always will end up like that. But I get you. Just, yeah, that was fine, what you did. And then negative divided by negative is positive 5. So we have our stuff now. Y-intercept is 5. And the slope says we should go up 5, right 2. Okay, I also did this just to show you. You don't have to do it. All I wanted to show you was this. This means going what and what. If I just had kept the negatives, it would mean to move how on my graph? Down 5, left 2. If I move down 5, left 2, do you understand I'm still walking on the same staircase? Does that make sense? It's like backtracking a step on your staircase, right? Okay, I'm making you go backwards here. So write an equation. So I'm going to use y equals mx plus b as my format. Y equals something x plus b. Okay, what is the y-intercept? Let's do that first. What is the y-intercept? So plus 1 is at the end. And what am I doing to get to the next point? Up 1, right 1. So my slope is 1 over 1, which I'm not even going to write because it's the number 1. And that's it. Got an equation. Okay, what is the slope? So here is an equation on your formula sheet. This is the equation that would be on your formula sheet for slope. Does it make sense as a formula? What is the rise? The change of the y, the change of the height. What is the run? The change of the x. So y's change, x's change. The rise is the y, the run is the x. Right? Okay, let's label some stuff here. I'm going to call this x1, y1, which means the x value of the first point, the y value of the first point. So then this would be x2, y2. So this is filling in to an equation. Okay, what happens when you subtract negatives? They add, so that becomes 4. And, oh, there's another, subtract negative. Okay, if you aren't really a formula kind of person, you could kind of think about where do they land. So -5, -3, and 2, 1. How much did I have to go up and over? And you can figure it out like that. Okay? What is the equation of a line that is parallel to this one and has a y-intercept of 3? Okay, so here's what we're going to do. We're going to figure out the slope of this line. Okay, so here's what I'm going to do. -8y equals, I'm trying to get y alone. So -8y, then I would move, so -7x, -3. Algebra moves. Keep y, move x, move number. Divide, divide, divide. Okay, how did our algebra go? Did we all end up with a slope of 7/8? Okay. Now, what does a parallel slope mean to you? The exact same. If you are parallel, you have the exact same slope. So my final answer would be that I need a slope that is still 7/8 and a y-intercept of 3. So can you piece those two things together? that's what I want as an equation. My slope is parallel to the one that's on that line, but mine has a y-intercept of 3. Okay, write the equation of this graph. There's a few of these on your exam. Okay, it's a special line. This is special. It's special because it's straight up and down. So here's your two options. Let's say I give you a multiple choice. Is it going to be x equals 8 or y equals 8? Those are your two choices. There's no, this line does not have two letters in it. It's only got the one letter in it. So what if I forget? I'm going to give myself a couple points. Every single point on that line has what? The same.
X.
No matter where you are on that line, every single point has an x value of 8. Okay, does everybody know what a y equals line looks like then? Horizontal, flat. Write an equation for a line that is perpendicular to this one, and it goes through the coordinate there. Okay, so what is the slope of this line? Can you figure that out? The slope of this one that's already drawn. Negative a half?
Yeah.
Negative a half. We're skiing downhill, so we know we're negative. Okay? So what is a perpendicular slope? What do you do with perpendicular? Do you remember the rule? Switch them and opposite sign. So this is going downhill, so ours will go uphill, so positive. So that's our perpendicular slope. And we go through this point. So I'm going to use this format. So I gave you two equations for your formula sheet. So you can have this version, which is called point slope. So I'm going to use this if I have a slope and a point. I use the other one if I have a y-intercept. Okay, how does the coordinate have to look in your formula? When you put it into your formula, the points are always what again?
Opposite.
Opposite. So the x has to say +3 and the y has to say subtract 3. And that's it. But I'm going to draw it. So I already drew the point for you. Can you go up 2 and right 1? How does it look? Would you say they're meeting each other at 90 degrees?
How did you know where for those squares?
Because I already have the coordinate there, and then I did up to right 1 and did another coordinate. Okay, we're going to do a little bit of trig and then we're done. I only have a couple questions on here, so. All right, with trig, you had 3 big ideas. You ready? You had Pythagorean theorem. Okay, I think I gave you a bright pink paper with trig. Pythagorean theorem. That's used when you're trying to get a side. You have two sides. You try to get a third side. Then you have, do you remember, SOHCAHTOA?
Oh, yeah.
You can use it to get sides, or you can use it to get angles. If you are getting an angle, what's the button process on your calculator when you figure out what the angle is? Anybody remember that button? How do you always get an angle at the end on your calculator? You use the magical button that's called second function. Yep. Inverse. Okay. So here we go. Which strategy is used here? The theorem. Should I add or subtract? Subtract. This is the longest side,
Wait,
and we're trying to get a shorter side.
can we just recap what SOHCAHTOA is?
We will basically as we're doing the questions, if that's okay. Okay, so I want to figure this out. So 21 squared minus 14 squared. We're subtracting because we said, hey, that's a shorter side. Yeah.
Could you go up to the last question?
Good? Okay. Ooh, I did something wrong. What's the thing I haven't done yet? I have to square root that, yeah, right? Would you notice that that answer looks a little bit extreme for that triangle? Okay. On your exam, I can't remember if it's a multiple choice. I'm not sure if it's expressed as a decimal or just left as a radical. It could have been a decimal or a radical. Okay, here we go. SOHCAHTOA. We are solving for this up there. Okay, if I'm given the angle 62 degrees, can you put these three letters on this triangle? According to 62 degrees, which side is O, which side is H, which side is A? In this triangle, according to the 62 degrees, which side is opposite? Which side is adjacent? Which side is the hypotenuse? Okay, do you remember those locations? Hypotenuse is always across from the 90 or the long. Okay, I don't care about which letter. Which one is irrelevant to me? This is irrelevant because I have this and I want that. Okay, which one should we pick? SOHCAHTOA. We're going to pick the SO method. So it goes like this. SO means sine of 62 degrees equals the opposite side, 25, over the hypotenuse. I'm going to use the letter C because that's, I guess, what it's called. Now, here was my trick. Put it over 1. And then crisscross. Cross multiply. This times this divided by this. Do you have your process down? Which two connect to times? Times, and then divide. 25 times 1, divide by sine 62. I will try to remind you on your exam, this is critical that your calculator is in degrees at the top. If you're in something else, you're going to get them all wrong. How did we do with an answer? 28.31? Okay. Same idea. There's a 28 here, so which side is opposite of it? Which side is adjacent to it, and which side is a hypotenuse side? So you always have OAH. There is one on this that is irrelevant for me. Which one do I not care about? I don't care about the H. It's irrelevant for the question. So, ka, or toa. Which one would you pick out of this now? Toa. So, tan.
Why did we scribble out the H?
Because I don't need it. I have 12. I want to know this. So there's the third side is irrelevant. So tan 28 equals OA. So that's a 12 over an X. And then I just always throw this over 1. And then it makes me realize what should I multiply and divide. So this looks like it's the same idea as the last. By the way, for the most part, I feel like this class really rocked this part of the test, this trig stuff. So hopefully you still remember it and get some lots of points on your exam. It'll come back. Just practice a few, it'll come back. Like riding a bike. Okay, one more like this. OAH, give me OAH. Give me an O, give me an A, give me an H. Which one is irrelevant? I'm going to pick the ka. Are we okay with that? I'm picking ka. So the cos of 57 equals the A over the H. I'm going to put that over 1, which means I multiply. I have to multiply this now. This is a different setup now. You have to multiply. See if we can match our answers here. How are we doing? 13 and change? Everyone's getting there? The typing, who do we still have with backwards calculators? Backwards still? Okay. And you're backwards still? You got that mastered? Okay. Okay, give me an O, A, and H again. And we're trying to find that one. This is the angle that we're talking about. So give me the opposite of this angle. Give me the adjacent to this angle. Give me the hypotenuse to this angle. Okay, I'm going to cross off the H. So that leaves me with TOA. What do we do if we're getting an angle? So tan inverse. And I'm going to inverse the O divided by A. So O divided by A. Okay, that's always the rule. Grade 11, same thing. Always inverse to get angles. We got to make like a rhyme or something with that. Inverse to get angles. Okay, last example. We have a kite. There's my kite. It is, here's the ground. We're 115 feet above the ground. The length of the string to the kite is 150 feet. So the person is flying it. There's the string. The string is 150 feet. Find the angle to the nearest degree that the string makes with the ground. Figure out that angle. OAH. You always got to find your OAH labels. If you know that angle, what's O to that? What's A to that? What's H to that? O, A, and H. Would we agree that we don't care about A? Scratch off. So, ka, or toa. So, I got my O and my H. So this is an angle. So I'm going to do sine inverse. And then the ratio is the O divided by H. Sine inverse of the OH. Did you get 50 degrees? O divided by H, sine inverse.